Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another video for you all. And in today's Algebra 1 lesson, we're going to be looking at the systems of equations. Now, not just the brief overview, but the specifics on the three major methods, of course, those being elimination, substitution, and graphing. So we'll break apart each of one of those individual methods, and I'll be showing you how to use them and when to use them when coming across these systems. But before I get into the lesson, please make sure to do 4 things. Hit that subscribe button, turn on post notifications, leave a comment down below, and also hit that like button on this video. So once you've done all 4 of those things, let's get right into the video. So solving systems of equations. Let's take a look at a brief overview of what the 3 methods are and what their purposes are. So the 3 methods to tackling a system of equations would include the substitution, elimination, and graphing methods. All 3 of these methods would work when you're trying to isolate and you're trying to solve for your variables. And oftentimes this would be in the form of y and x when you're looking at your regular linear equations like y equals x, any of the translations of those. So it's going to be y and x, your 2 variables within 2 separate linear equations, and then obviously you're going to be trying to solve for both utilizing these methods. All of these methods will work for any system. So if you're given any system at all, any 2 linear equation systems, you would be able to solve them with any of these 3 methods. However, substitution, elimination, and graphing, they work better in certain circumstances, and it can save you a lot of time. Now, the way that I like to think of substitution and elimination, it's just when you're able to apply it in a sense, which one would be better in the situation. Very rarely are you going to actually use the graphing method, because graphing method takes a little bit longer than the other 2. However, it's a very, if it's a very large, system, and obviously you have a graphing calculator on hand, it would be very useful. So method 1, this would be substitution. Substitution is when you alter one linear equation, one of the 2, in terms of one variable. So if you're given y equals 2x, you're going to write 2x in terms of y. So you have what y is equivalent to. Then you're going to take that given y equals 2x, and you're going to plug it into the respective value for the other equation. So the other equation is going to have another y and an x. You're going to plug in the known value for y, 2x, into that equation. And what that does is you'd be creating a relationship. You'd be substituting your second variable with the first variable so that you're only solving for one variable in one equation. So once you set y equal to 2x, you know that y is also 2x. That's another way of writing y. So you're going to plug in 2x into y in your next equation so that that whole equation is going to be in terms of x, and you'd solve it like a regular equation. Once you solve for one of those variables, say for example x in that second equation, you're going to plug that x back into the simplest equation and solve for the other variable y. Remember, this is two variable system, so you need to make sure you're going back and substituting your solved variable for the unknown variable. So let's put this into action. Let's actually solve using the substitution method. So in order to solve, what we're going to do is we're going to set one of these equations equal to one of our variables. Now I'm looking over here at 2x plus y equals 7. This is going to be our simplest equation. It's a lot simpler than this guy right here. So we're going to simplify this. We're going to put it in terms of y because y is already isolated. Y does not have a coefficient, so it's easier to simplify. So let's subtract 2x from both sides, minus 2x, and we're left with y equals negative 2x plus 7. All right, and then up top here, we have 4x minus 6y equals negative 26. Now that we've essentially solved for what y is, we can merely plug this value in for y in this equation in order to isolate for our x variable. Now that we've solved for what our y variable is, it's going to be y equals negative 2x plus 7. We're merely going to plug that in for our y value in the respective original first equation. So that's going to be 4x minus 6y equals negative 26. So 4x minus 6. We know what our y value equals, so we're just going to substitute that for y. Negative 2x plus 7, and that equals negative 26. Now we can merely distribute this and put this all in terms of x. So the only variable that's going to be in this equation is just x. So 4x, negative 6 times negative 2x is going to be plus 12x. And then negative 6 times 7, that's going to be negative 42. That equals negative 26. We'll add these x's together, so that's 16x minus 42 equals negative 26. Then we're going to add 42 to this side just to isolate our x on the left-hand side, solving for it. And we're going to get that 16x is going to be equal to 16. So that's simple. X is just going to equal 1 when you divide both sides by 16. Now we found the value for our x. Now we just need to find the other value, our y. You cannot stop there. So we're going to take our simplest equation here. Since it's simpler, it takes less time. We want to be more efficient. So we're going to plug in what we know for x is 1. So 2 times 1 plus y equals 7. Then now the only variable in this equation is just going to be y, so we can really solve for y. So 2 plus y equals 7. So that means that y must equal 5. So our solution is going to be a coordinate point. It's always a coordinate point, because if you think about solutions, it's where two lines intersect. So it's always going to be a coordinate point of values. So it's going to be 1 and 5. So at 1, 5 is where your solution is going to be. So 1, 5. And that's your solution. Now let's take a look at method 2, which is our elimination method. This is my personal favorite, especially when you get somewhat more complicated numbers. Oftentimes they can have smooth solutions, and this is probably the most efficient. So elimination is when you multiply a linear equation by a factor in order to cancel out one or two variables when adding both equations together. So in doing so, you'd essentially be canceling out one of the variables, or at least one of the variables. It is by chance, if you multiply that by the same factor, both variables cancel out. And you might get infinite or no solutions, but I'll explain that at the end of the video. But once you do that, you'll have at least one of your variables canceled out, and you'll be able to solve smoothly for the other isolated variable, just like we did here. Instead of substituting it in, you're automatically canceling them out, and you're just solving a simple equation for one variable. And then obviously, once you're done that, you're going to solve for your first once you solve for your first variable, you're going to plug that back into the simplest equation, whichever one's shorter, and you're going to get the value of the other variable in order to complete your solution set. So method 2 solving, let's actually solve with elimination. So we have 4x minus 6y equals 14 here in this equation here. So what we're going to do is we're going to multiply this equation here by a negative 2. Now the reason why we're doing so is because I see that 2x and 4x, well, 2x is merely a factor of 4x. So we can multiply by negative 2, not just 2, but negative 2 in order to make our 4x and our x cancel out when we're adding them together. We're going to add these equations together. So we're going to multiply by negative 2 because we want to make negative 4x essentially cancel out with 4x, so we're just left with our y's. So when we multiply that together, negative 2 times 2x is negative 4x. We add that to 4x, that's going to cancel out. So that'll be we'll simplify this here first. So 4x minus 6y equals 14 minus 4x minus 2y equals negative 14, because I'm just multiplying this 2 out to each and every single one of these terms here. So once I've done that, I'm just going to cancel out our x's here. So 4x minus 4x is going to be 0. Then negative 6y minus 2y is going to be negative 8y. And then if we add together our negative 14s, that's just going to equal 0. So we're left with negative 8y equals 0. And obviously when anything equals 0 with our y multiplied by our negative 8, we know that y must equal 0. Now that we figured out what y is, we're going to plug it back into our simplest equation, being 2x plus y equals 7. So we're going to plug this back in. So 2x, we're solving for x, obviously. We're given y, so that's 0 equals 7. 2x is going to equal 7 in this case, and that means x equals 3.5 when you divide both sides by 2. So our solution to this equation would be our coordinate points, that's 3.5, our x comes first, comma, our y value, which is going to be 0. So it's going to be an x-intercept. All right, on to the final method, and this is going to be method 3, which is all about graphing, our last step. So graphing, when you graph both of your linear equations, it's when you're essentially creating a visual representation, and this shows you how you figure out where they intersect as your representative solutions. So wherever your graphs are essentially intersecting, that's going to be your solution set, because that's where the graphs are equal for the respective x and y values. So this point of intersection will contain the solution to both of your variables, as it shows where both lines are essentially equal to each other. So after creating both of your graphs, if you only see one line, that means you have infinite solutions. So infinite solutions means both of those lines will overlap essentially. That means they're the same line. But if they have no solution, and as I was saying, obviously your one solution is just going to be that one point, what we've been practicing so far. So that's just when one intersection happens. No solution means that they're both parallel, and I'll explain that in later videos to come, and they don't have any intersections, so there's no solutions at all. And then infinite solutions mean both of your lines are going to interlap, and they're going to have infinite solutions, meaning infinite solutions, any points Any variables, any values for your variables will work. No solution, no values for your variables will work. And one solution would mean that only one specific coordinate would work. And how to see how infinite solutions would work. Say, for example, if you have two constants equal to each other, like 7 equals 7, when you simplify both equations, that would be infinite because it's always the case. But if you had two constants that did not equal each other, 7 equals 8, that would be no solutions. And obviously, one solution would be if you had a variable equaling a value, essentially, like x equals 8. That would be one solution. All right, now let's get to our graphing. So method 2 solving, this is going to be solving using graphing. I apologize, it should be graphing. So when you're solving using graphing, you're going to be given two equations, obviously, and you're going to graph them together to see where they actually intersect. So this part will actually be graphed on desmos.com. So I will switch to that. All right, so now we're here at desmos.com, and this is our graphing calculator, a very good resource to use when you're trying to graph and see things visually. So if I were to graph our two equations, essentially, y equals 2x and y equals x plus 7, you can see the actual visual representation of the graphs. Now, what we're looking for is any points of intersection. Now, you can see here, obviously, these points are not going to be, these two graphs are not going to have infinite or no solutions. You can see there's a clear indication of a intersection point, and that's going to be the only point that they intersect. So if we were to click on this point, we can see that the point of intersection would actually be at 7, 14. So our x value here would be 7, and our y would be 14, because at this point, both of these lines are going to be equal for the respective variables. So if we were to switch back, if we were to now that we're back here, you can see that our solutions for this equation is going to be that x is going to equal 7, and our y is going to equal 14. So that's going to simplify to 7, 14 as our solution set. So that's going to be our solution to this equation. All right, everyone, so that'll be it for today's video. I hope you all enjoyed. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Visit our website at www.ecoreacademy.org. Email us at ecoreacademy@gmail.com. And check out all of our socials, links in the description box down below. They're really fun and interesting, and a lot of them are, outside of the general academic scope, just to take you away from, give a good distraction to your day, give you some good information as well. So I hope you all enjoyed this video. This has been AJay Raj, and I'll see you guys in the next one. Peace.